All right, so I'm going to look at mixed problems, which are very much similar to mass problems in that you have to do all three steps. The difference being that maybe the third step, instead of going back to grams, will go to liters. Now, the very first thing I recommend after reading the problem is that you annotate the equation. So, right off the bat, it says what volume of NH3? So I'm going to put a little question mark right there under the NH3. And then it says 25 grams of N2, the nitrogen. So I'm going to put 25 grams right there. In the process, I have just identified what the mole ratio is going to be, my step 2. It's going to be the number in front of what I want to find out, what I don't know, the 2, divided by the number in front of what I already know, in this case, the nitrogen. And if you're like, well, there's no number there, well, that's all right. It's always a 1 if there is no number there. So, first step, go to moles. So in this case, we're going to take the 25 grams times 1 mole over, since it's N2, that's 28 grams. The mass of nitrogen is 14. We got 2 of them, so that's 28. And I'm going to end up with basically 0.893 moles of N2. All right, now, second step, mole ratio. So I'm going to take that 0.893 moles and then put in my mole ratio, 2 over 1. The 2, well, that's what I wanted to find out. And the 1, that's what I already know. And so I take 0.893 times 2, and basically I'm going to get 1.786 moles. But now it's the NH3. And then third step, I'm going to go to in this case, go to liters, because they want volume. Volume means liters. So I'm going to take my 1.786 moles times 22.4 liters per mole. And basically I get 40.0 liters of NH3. It's really helpful to do this labeling because both of these are moles, but I'm keeping straight just what it is I'm trying to do. And again, in the stuff that you were doing from yesterday, the only difference was the third step. Instead of going to liters, we would have gone to grams, and so instead of the 22.4, we would have said 17 grams because that's the molar mass of NH3. All right, problem 2. This time, what volume of O2? So again, there's my question. And I got 5 grams of KClO3. So first, 5 grams times 1 mole. KClO3 adds up to 122. 39 for the potassium, the K. 35 for the chlorine, and 48 for the 3 oxygens gives me that 122. And, basically this comes out to be 0.04 moles of the KClO3. Okay, second, I'm going to take those 0.04 moles times, well, now I got the mole ratio step. Again, question mark on top. The question mark is with the O2, that's a 3. The KCl, that's what we already know. KClO3, that's a 2. So my mole ratio, 3/2. Question mark part on top, that's going to give me 0.06 moles of O2. And then third step, take the 0.06, and we again want volume. It's the same number all the time for volume. Doesn't matter what gas it is. So it's 0.06 times 22.4, and basically it's going to come out 1.3 liters of O2. So 3 steps. Now in problem 3, it refers to problem 2, so I don't need to repeat step 1. I already have step 1. I can now go right to step 2, the mole ratio step. Okay, so I'm just going to say second. I'm still going to take my 0.04. Okay, because that's still what I was told in problem 2. That's the KClO3. I'll just label it here. Okay, now times my mole ratio. But now my mole ratio is 2/2. Okay, because the question mark is now over here. So that has a 2 in front of the KCl, so that's why it's a 2 on top. The only thing I knew to begin the problem was the KClO3. That had a 2 in front, so that's 2/2. And of course, 2/2 is just 1. And so I'm going to end up with 0.04 moles of KCl. And now I can go to my third step. I want grams. So really, when you get right down to it, this is a mass problem. I started in grams, and I'm going to end up in grams. 0.04 moles times, let's see, we got 74 grams per mole. Again, 39 for the K, 35 for the Cl, so that's 74. And end up with 2.96 grams, or we could just say 3 grams of KCl. And so I didn't have to redo everything for that one. All right, problem 4. Oh, that reminds me. Sorry about that. For some reason, the arrows got left off. So let me get them back in. Let's see, and then here. The fact that problem 2 said decompose, when we decompose, we went from one thing into 2 things. So there's where the arrows should have been. That's a little bit confusing not having those there for sure. All right, problem 4. What volume of hydrogen? So now my question is over there. 2.5 grams of zinc. Right there. So I'm going to go 2.5 grams times 1 mole over, since it's zinc, I'm just going to round it to the whole number, 65 grams. Now, my mole ratio, question mark on top, well, there's nothing there, so that's a 1. And there's nothing over there, so that's a 1. So my mole ratio is 1/1. And then I want to go to volume, so it's going to be 22.4 liters per mole for the hydrogen. And that's going to come out to be 0.86 liters. Now, what's a little bit different in number 4 than what I did in problems 1 and 2 is I chained it together. So really, this part here is step 1. This part here is step 2. And then this is the step 3. The only thing is I didn't actually write down like the mole amounts. But if you'll note back in problem 2, I found the moles and then I turned right around and used that moles in step 2, got new moles and then turned right around and used those moles in step 3. I don't really need to do that at all. I can just chain them all together the same way that if I was going, say, from miles to kilometers, I could go miles to feet, and then feet to inches, and inches to centimeters, centimeters to meters, and then meters into kilometers. I don't have to have all the in-between numbers. All right, number 5. Okay, we got how many molecules of water? So that's what I want to know. 2 grams of sodium sulfate. So there's what I already know. And again, there aren't any numbers in front of them. So my mole ratio is going to end up just being 1/1. So first off, step 1, 2 grams, 1 mole divided by 142 grams. That's 2 sodiums, 2 times 23, 1 sulfur, that's 32, 4 oxygens, another 64. And this is going to be 0.014 moles of Na2SO4, the sodium sulfate. Okay, step 2, my mole ratio step. I'm going to take that 0.014 moles times 1/1. Of course, anything times 1 doesn't change. What has changed is, what is it I'm talking about? I'm talking about the H2O. In other words, the recipe says that however much in moles that I make of this, I have to make the same amount of moles of that. And then 3, I have now we're going to go to molecules. So I'm going to take the 0.014 moles times the 6 times 10 to the 23rd molecules per 1 mole. And I end up with, it looks like 8.45 times 10 to the 21 molecules. Notice that I'm writing the entire amount out. And, just to, again, here, I go to moles. That's always my first step. It's always a divide. Okay, here, mole ratio. That's my step 2. And then 3, go to desired units, which in this case were molecules. In some of the other problems, they were grams or liters, but always 3 steps for these problems. Okay, last one. I have 10 grams of aluminum chloride. They're decomposed, split apart, and they want to know how many molecules of Cl2. So there's the question. So I'm going to chain this together. 10 grams times 1 mole over 132 grams. The 132 comes from 1 aluminum, that's 27, and 3 chlorines, 3 times 35. Okay, now my mole ratio step. Okay, question mark on top. That's the question. How much chlorine? What is it I already know? I already know 10 grams of aluminum chloride. And then I want to go to molecules. So 6 times 10 to the 23rd molecules per mole. And oh, by the way, those cancel, and I have my answer in molecules. The final answer here being 6.8 times 10 to the 22nd molecules. And again, this was step 1. Here, that's step 2. And then this part is my step 3. 3 steps to do mixed problems. I call them mixed problems because we're changing units. We're going from grams into liters or molecules, and it can be in any direction that you want.